Okay, welcome to lesson 5.4, factoring and solving polynomials. This is video 3, so we're going to be solving. We're going to be actually solving the polynomials. So basically the difference is you're going to have to make sure, and when you're solving these problems, you need to first of all read the directions very, very carefully. If it says factor, then you're actually going to stop just like you did in video 2. So we're just going to factor them and write them as the different factors. If it says solve, you're actually going to have to go one more step and solve these. So the very first thing we're going to do, we're only going to look at a couple of examples because the factoring on all of these actually ends up all of the same. So all of the rules and everything that we talked about in video 2 all remain the same. The only different part is now we've got one extra step and we've actually got to find out what x is going to be. And the way we're going to do that is we're going to factor all of these. Okay, so let's go and take a look at the first example. So the first example is 2x to the 5th plus 24x equals 14x to the 3rd. So the very first thing that you need to do when you're actually solving these is make them all equal 0. Okay, now we may use different strategies, but they all have to equal 0. So the very first thing that we're going to do is we're going to subtract a 14x to the 3rd. And whenever you have multiple exponents like this, always write it in descending order. So 2x to the 5th minus 14x to the 3rd plus 24x equals 0. Okay. And a couple of the strategies that you need to look for is, first of all, do you have a monomial that you can factor out? Let's try this again. Do you have a monomial that you can factor? Okay. Once you have a monomial that you can factor, and you factored that out, then you need to look for your special cases. In other words, like a difference of squares. Do you have a perfect square? Or do you have a sum or difference of cubes, like the ones we talked about in video 2? Okay, so those are a couple ones. Then the next step is, can you factor the trinomial? And there's kind of several of these. Can you factor a trinomial? Can you factor by grouping? And these are in no particular order. Or maybe, so those are usually the most rare occasions that you're going to see. Factor the trinomial, factor by grouping. Oh, and maybe the quadratic formula. Okay. So typically you're going to use the quadratic formula to solve them if you can't find any factors. So alright, so let's go ahead and take a look at this one. So the first thing that I notice, I have a 2, a 14, and a 2. So the first thing I notice is I can actually factor out a 2. The biggest number I can divide them all by would be a 2. They also have an x to the 5th, an x to the 3rd, and an x. So I could also pull out an x. Okay? So what I'm left with is 2 divided by 2 cancels. X to the 5th divided by x gives me x to the 4th. 14 divided by 2 gives me a 7. X to the 3rd divided by x gives me x squared. 24 divided by 2 gives me a 12. And x divided by x cancels out, equals 0. Okay. Now don't forget, we have to have that 2x in front of us at all times. We can't lose that. So now I notice that I have a special case trinomial. And my special case is, since this is a 1, then I can just simply look for the factors of 12 that add up to be a negative 7. So anytime I have a trinomial, I can do that. Okay, we'll do with the x to the 4th in just a moment. But remember, negative 1 times 12, negative 2 times 6, none of these are adding up to be, oh, sorry. Actually, we need a positive 12, so let's start over here. So I need a 1 times a 12, 2 times a 6, none of these are adding up to be 7. 3 times 4 gives me 7. But remember, I need a negative, so I'm going to change both signs. A negative 3 times a negative 4 gives me a positive 7. But a negative 3 and a negative 4 gives me a negative 7. Okay? All right. So 2x, and now I'm going to break this up. X to the 4th minus 3. X, oops, sorry. Gosh. the square root of x to the fourth is x squared minus 3, x squared minus 4. Okay? So I break it up just like if it was x squared. Basically, I take the exponent and divide it by 2. Okay? Now, I quickly find out that I can't do anything with this one. That's as far as that I can get it. If you're factoring, I can do 2x, x squared minus 3. This one is a difference of squares. That's a perfect square. That's a perfect square. So I could actually take this one one step further and do 2x plus 2, 2x minus 2. Okay? Once you get to this step and you find out that I factored everything as far as I can factor, then each of these products, the 2x, x squared minus 3, the x plus 2, and the x minus 2, you just set them all equal to 0. So I'm going to do 2x equals 0, x squared minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0. Okay? So now I solve each of these. Divide by 2, so x could be 0. This one, remember I have to add 3, and since I have an x squared, I have to take the square root. So I actually get x equals the positive or negative square root of 3. This one I minus 2, so x could be negative 2. And this one I add 2, and I get x equals positive 2. Okay? Now remember, when we were talking about degrees a few lessons ago, the degree of this polynomial would be 5, because that's the biggest exponent that we have on one of the terms. So if you look at this, you should have 5 answers when you're done. Okay? So I have 1, 2 counts the negative, 3 counts the positive, 4, and 5. So I've got all of my possible answers on this. Okay? So my actual answers, a lot of times you'll see these written as a bracket or with a brace. So I can have 0, plus or negative the square root of 3, and sometimes they may break those up into 2 different ones, a negative 2 and a positive 2, just like I did the positive 2 and the negative 2. Okay, so there's 5 possible answers. Okay, all right, example number 2 is x to the third minus 27 equals 0. Okay, now let's go ahead and take a look at our possibilities. So if we notice, I don't have any monomials. Okay, so here I have an x to the third minus 27. Okay, they have no numbers in common. It's already equal to 0, and 27 doesn't have an x. So then I need to look for my special cases. I don't have a difference of squares, because remember the first one was a cube, but I do have a difference of cubes. Okay, because the cube root of x, so remember we were going to write that out in terms of a. The cube root of x, or x to the third, is just x. The cube root of 27 is going to be 3. Okay? So, remember when there's a minus in there, I break it up into x minus 3. And if you need to refer back to your notes to look at those, that would be a great idea. Okay? All right. So then I'm going to square this, x squared plus, multiply them together, 3x plus, take 3 and square it, and I get 9. Okay? And don't forget equals 0. Okay? X minus 3 is broken up as far as I can get it. The second part here, I need to look for factors of 9 that add up to be 3. So I get 1 times 9 doesn't give me 3. The next one would be 3 times 3, and that one doesn't add up to be 3. So what I actually have to do in order to solve this, so the first thing is I should separate these, x minus 3 equals 0, or x squared plus 3x plus 9 could equal 0. Okay, so this one's easy to solve. Let's go ahead and solve this one. Add 3, and I get x equals 3. Now, since I can't break up the trinomial that I've got, what I actually need to do is, the only other method, there's actually a couple methods that you could do. The choice is actually up to you to solve it however you choose. You could do a perfect square, completing the square, where you subtracted the 9 and then added the variable to the side, or you could do the quadratic formula. Now my preference is to go ahead and do the quadratic formula. Okay, so since we can't use this, let's go ahead and get rid of that. So we've got the board space. So if I do the quadratic formula, remember it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So, remember, this is my A, B, and C. So, negative B gives me a negative 3, plus or minus square root of B squared is 9 minus 4 times 1 times 9, all over 2 times 1. So, negative 3 plus or minus 9 minus 4 times 1 times 9 gives me 36. 2 times 1 gives me 2. So the negative 3 plus or minus the square root of actually ends up with a negative 27 all over 2. Okay. Now remember, I can't have negatives under the radical sign, so I'm actually going to pull out my I for my imaginary, and I have a 27 under there. So then I just need to know, remember when I'm breaking up 27, gives me 3 times 9. Well, 9's a perfect square, and this one gets stuck under the radical. So this is actually going to get simplified as negative 3 plus or minus square root of the square root of 9 is 3. So I get 3i square root of 3, because the other 3 gets stuck under 2. Okay? And if you remember, my degree of this one is a 3. So I should have 3 answers. A couple of those may be imaginary. So here's the first one. X could be 3. The other one is negative 3 plus 3i square root of 3 all over 2. And the other one is negative 3 minus 3i square root of 3 over 2. Okay, so there's your 3 answers. Okay, so, all right, well, this completes actually the last lesson in Algebra 2. So once you're finished with the quizzes and the unit test, remember that you'll need to make arrangements to take your final.